So this is technically the second day of factoring, right? Of reviewing of factoring. And up until this point, you should know how to pull out the GCF. That's the first type of factoring that you learned. That's the first type of factoring you should always attempt. Pull out what's in common from all your terms, if there is a GCF. Also, you should know how to factor standard form quadratics when your a value is 1. Okay, so that means that when there's no number in front of the x squared, you could set up parentheses, x, and then you simply think what times what is a c value that if you combine together is a b value, and you put those numbers right in there, and that will be your factored form. And the tip I give is to make a list. That way you could see the numbers and combine them and see which pair of numbers works that would belong in here. Okay, and we also learned yesterday, or reviewed yesterday, on how to factor perfect square binomials and perfect square trinomials by applying square roots. But you need to check your answers because it doesn't always work out. And by the way, sometimes I ask you to factor something and it's simply not factorable. For example, let's say I told you factor 3x plus 11. And I ask you, factor something out of there, you can't factor anything, right? There is no multiple of 3 in both terms, there's no multiple of 11 in both terms, there's no x's in both terms. That would simply be not factorable. Now, what does that mean? That you are not able to factor, right? So there will be expressions that are simply not factorable. And yesterday we also learned that the reason why we're factoring, which is a reverse distributive property, is to get multiplication. That way we could apply the zero product property to split them and to solve quadratic equations. But anyways, on this section, we're only going to be practicing factoring. So right here on number 1, our a value is 1, which means we could jump right into the format, parentheses, xx, and we could think what times what is our c value, which is negative 64, that if I combine together is my b value, which is negative 10. So I highly recommend making a list of the multiples of your c value, in this case negative 64. And I always say start out with the number 1, or in this case, because it's a negative 64, start out with negative 1. So negative 1 times 64. And then negative 2 times what? 32. How about negative 3 times, will that give us something? No, that won't work. How about negative 4 times something? 16? Okay. How about negative 5? Nope, that doesn't work. How about negative 6? Nope. Negative 7? Nope. Negative 8? 8? Okay. And I believe that's about it, right? Unless I missed something. But I went through every single number, 1, 2, 3, 4. And if you're not good with multiplication, you could get a calculator and do 64 divided by 2, and it'll give you that 32. Try 64 divided by 3, you're going to see that it gives you a decimal, so there is no multiple with 3. Try 64 divided by 4, it'll give you 16, right? So with the calculator, you'll be able to come up with this list pretty easy. After you come up with the list, it's simple. All you got to do is combine and see which pair of numbers combines together to give you the middle value, which is negative 10. So in this case, so after combining this gives us 63, this gives us 30, this gives us 12, which we see that we need a negative 10. So none of these, this will give us 0. None of these work. So what does that mean? That it's simply not factorable. So we're definitely going to have some of these on the assessment this Friday. I don't know, pick one. Which one would you like to see? Or should we just go through them all? Go through them all. Number 2. All right, because the a value is 1, we could set this up. That's because there's no number out here in the front. Because if you have this in factored form, x times x will give us that x squared. If I had a 6 right here, I wouldn't be able to set up x and x. If I had a 6 right here, it might be a 3 and a 2, or a 2 and a 3. It gets weird, right? Or a 6 and a 1. But anyways, there's no number. That's why we're able to set this up. And then you simply think, what times what is your c value, negative 12, that if you combine together is your b value, which is negative 7. I always say make a list. Negative 1 times 12, negative 2 times 6, negative 3 times 4, and that's about it. All the possible ways of multiplying two numbers together to give you the c value, negative 12. Now, which pair of numbers combines together to give you the middle value, negative 7? Well, if we combine these two, it doesn't work. It gives us 11. If we combine these two, it gives us 4. If we combine these two, it gives us 1. None of those again. So that's weird, but it's not factorable again. Not factorable. Continuing on, number 3. Set it up, parenthesis, 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 x. What times what is the c value negative 6? That if I combine together is a b value 5. Make a list of numbers. What times what is negative 6? Well, negative 1 times 6, negative 2 times 3, and that's it. Which pair of numbers combines together to give you the middle value, positive 5? Negative 1 and 6. So we're going to plug in the negative 1 right there and the 6 right there, and that is our factored form. Cool? All right, number 4. Because there is no a value, because the a value is 1, we're able to set up parenthesis, 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 x. And we think what times what is our c value of positive 24, that if we combine together is a b value of 8. Make a list. I'm going to start with 1 times 24, and then what? 2 times 12, and then 3 times 8, and then 4 times 6, and then 5 times nothing. Okay, so that's it. Those are all the possible ways of getting the multiples that give us 24. So which pair of numbers combines together to give us the middle value 8? And that would be none of them. Again, right? If we combine 1 and 24, that gives us 25. That gives us 25. That's not a 25. This is 14. That's not a 14. This is an 11. That's not an 11. This is 10. That's not 10. So once again, are we kidding? I hope not. It's not factorable. Again, not factorable. Número 5. So right here, because the a value is not 1, you could set up parenthesis, 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 x, thinking what times what is my c value, which in this case is negative 64, that if I combine together is my b value, the middle term, but there is no middle term. So that would combine together to give you nothing, right? You could make a list with negative 1 times 64, negative 2 times 32, and so on, but that's ridiculous. We should recognize even more so that 64 is a perfect square number, right? So technically you could do, square root of x, square root of 64, square root of x squared is x, that's where we get these x's from. Square root of 64 is 8, put 8's right there. Because there is no middle term, then you have to have opposite signs for those middle values to cancel out. So this is technically a perfect square binomial, a difference of 2 squares. Or again, you could have thought what times what is negative 64, that if you combine together is nothing, that would be a positive 8 and a negative 8. Moving on. Number 6. What does that end up factoring to? Anybody? Not factorable? Let's make a list. How could I get 64? 1 times 64? 2 times 32? 3? Nope. 4 times 16? And 8 times 8. So if I combine 1 and 64, what do I get? 65. Is that a 65? No. 32 and 2 is 34. That's not a 34. That's 20. That's not 20. This is 16. That's negative 16. So it is 16, but I want it to be a negative. I have the right number, just the wrong sign. That means I have the right numbers, just the wrong signs. So change both of those to negative 8s, plug them in, and you're good to go. That's the factored form. Just a heads up, in case you're taking a multiple choice test in the future and you're looking for the correct factor form, they may give it to you like this. Because it's a identical binomial times itself, they might just write the binomial once and put a square on it. Either one's totally fine. Just to let you know. All right, how about number 7? It's definitely a perfect square. We could square root this first one, and we could square root this back one. Let's do that. Square root of 9x squared is what? 3 with an x. Square root of 1 is 1. Now, I need my final distribution to be 1 times 1 to give me a positive 1, right? So it's either they're both positives or they're both negatives, right? Now, you got to look at your middle term. The only way you're going to end up with negatives is if they're both negatives. Does that make sense? So you do need a minus there and a minus there. However, we should double check. Oh, I forgot the 3x right there. We should double check and make sure that this actually works, right? So let's distribute 3x times 3x. That is the 9x squared that we have right here. But then I go 3x times negative 1. That'll give me a negative 3x. And then negative 1 times 3x. That'll give me another negative 3x. And then negative 1 times negative 1. That'll give me the positive 1. But when I combine the minus 3x and the minus 3x, I get minus 6x. I do not get the minus 18x that we have right here. So did this factoring method work? No, it did not. So obviously it's not factorable. Again, no manches. All right. 8. Perfect squares. What's my factored form answer then? 2x, 2x. And what's the square root of 25? 5 and 5. Now what about the signs? One has to be negative, one has to be positive. It doesn't matter which one you put where, but they have to be different. Now this will work out. If you want 2x times 2x, give you the 4x squared. 2x times negative 5, that'll give you a negative 10x. Positive 5 times 2x, gives you a positive 10x. And the negative 10x and the positive 10x will cancel out. That's why there's no middle term. And 5 times negative 5 is negative 25. Should we keep going or should we skip around? Let's compare 9 with 10 before moving on. 9 is a difference of two perfect square terms, and we know that it'll work out beautifully. But if it's not a minus sign, it's impossible. So this one right off the bat is not factorable. You see, on number 9, when you think of the square roots, the square root of 4x squared is 2x. The square root of 36 is 6. Now, of course, in order for you to end up with a negative 36, you have to have one positive 6 times a negative 6. The signs have to be different, and that's how the middle terms will cancel out. So one has to be plus, one has to be minus. Doesn't matter which one you put where. That's a correct factored form of number 9. But if you try to do this one right here, and you do, the square root of 49x squared is 7x, and the square root of 25 is 5, the only way you're going to get a positive 25 is if they're both positive or if they're both negative, but then the middle term will not cancel out, so this one's not factorable. That one, what's the answer going to be? Or possible answer, possible factored form? Anybody? 2x. Yep, the square root of 4x squared is 2x, and the square root of 9 is 3, right? And what signs am I going to put in there? Are they going to be different, 1 plus, 1 minus? If they're 1 plus, 1 minus, the middle term will cancel out. So we do have a middle term. It can't be a plus and a minus. Are we going to either have a plus plus, a plus plus, or a minus minus? Minus minus, right? Because the middle term's negative. That negative has to come from somewhere. It's going to come from both of those being minus signs. If you wanted to, you could double check it, and you'll see that it does work out. Number 12. Any ideas? What's the first type of factoring we learned? Even before using the format on a perfect GCF. GCF. What is the common factor, or the greatest common factor of all three terms? There's definitely x's in each term, and the maximum amount of x's we could pull out is x squared, right? If we pull out an x squared on the inside, x squared times what gets me a x to the 5th? That'd be a x to the 3rd. X squared times what gets me a negative 2x to the 3rd? Be a negative 2 with an x, right? And how about x squared times what gets us back to a minus 4x squared? Minus 4. No need for x's. And that's it. Finally, we're to some fun questions like 13. Okay? 13, what could we pull out from all these terms? What is a GCF?
4.
There's definitely a 4.
4x.
And there's also x's, and the maximum amount of x's is 4. So yeah, 4x to the 4th is the greatest common factor. What's going to be left on the inside? 4x times what gets us 12x to the 9th? 3x what? 3x to the 5th, okay. And then the next term? Negative 4x to the power of 3, that's right, because 4 times negative 4 get you the negative 16, and 4 plus 3 gets you the 7. How about the next one? Minus 2x to the second power. And last but not least? Positive 6. No need for x's. Okay, finally we get to the really fun stuff. It says, see notes on factoring by grouping before doing the problem below. So let's go back to the page of notes I gave you yesterday, and we skipped over the top right column that said factoring by grouping. Okay, so here's the deal. Factoring by grouping is simply separating a polynomial into two groups. That's why it's called factoring by grouping. You factor something out of the first group, you factor something out of the second group, and then take a step back and factor something in common out of the whole thing. I know that sounds weird, but we have 4 terms right here. It says separate them into 2 groups. So I simply took the first 2 terms, wrote them, the second 2 terms and wrote them, but with the space between the 2. And I explained the steps. Step 1, separate into 2 groups. That's what I did, 2 groups. Step 2, factor something out of each group. So on this first one, let me zoom in. On this first group, what could I pull out? I could pull out x's. How many x's? An x squared. And that's what they show right here. Now if I did pull out an x squared, what's going to be left? X squared times what gets you back to the x to the 3rd? That'll give you an x, right? And then x squared times what gets you back to an x squared? A 1, so plus 1. So that's why I wrote this, right? But I showed my work, it's typed out right there. Over here, what could I pull out? I can't pull out anything. But for the sake of doing factoring by grouping, even if I can't pull out anything, just to go through the motions, I'm going to pull out a positive 1. Because if you pull out the factor of 1, it stays exactly the same, x plus 1. Right? So there it is, x plus 1. Okay, so that was step 2. Factor something out of the first group, factor something out of the second group. Step 3 is to take a step back and factor out the common binomial from both groups. So if you have a common binomial, which right here is x plus 1 and x plus 1, you could pull out that x plus 1. So let me zoom in again, and let me show you this. I want to do some exaggerated parentheses, some big giant parentheses, and I am going to pull out this x plus, both of these x plus 1s, I'm going to pull them out and put it out here in the front. So I'm going to pull out that, x plus 1 and put it out there in the front. Now, if I do pull out the x plus 1, what's going to be left? X squared. And if I do pull out the x plus 1, what's going to be left? A 1. So again, I'm doing exaggerated parentheses. I did exaggerated parentheses down here so you could see how it's working out. All right? The x plus 1 got pulled out, exaggerated parentheses with blank spots because you pulled it out from there. And now final step is to just write it with the correct size parentheses, x plus 1 times x squared plus 1. So we have factored a four-term polynomial using factoring by grouping. Now this is a very challenging factoring method that we must practice. So let's practice right here with this one. Step 1 is to separate it into 2 groups. That's why it's called factoring by grouping. So everybody on number 1 right here, go ahead and write it 3x to the 3rd plus x squared, leave a space, and then plus 15x plus 5. So I have 2 groups. First 2 terms, second 2 terms. Step 2, factor something out of each group. Even if it's not factorable, pull out a 1. All right, so we're going to factor something out of this first group. What could I pull out of there? X squared, right? There's x's in both terms. You could pull out the maximum of 2. So x squared is what we're pulling out. What's going to be left on the inside? 3x. A 3x. plus 1. Okay? How about that second group? What could I pull out? It says 15x plus 5. So we could pull out a 5, a positive 5, that is. Now, if I do pull out a positive 5, what's going to be left on the inside? 3x plus 1. Now, this is a good thing. Why is that? Because I do have a common binomial in both groups. That's the whole purpose of factoring by grouping, to have a common binomial that you could actually pull out of the whole thing. So let me do that right now. I am going to put some exaggerated parentheses, huge parentheses. I'm going to pull out that 3x plus 1 that's in common in both groups. And what's left over on the inside? X squared, and then the 5. All we need to do is write it with the correct size parentheses. Here it is, 3x plus 1 times x squared plus 5. This is your factored form of the original polynomial. If you did distribute, combine like terms, you'd end up with these 4 terms up here. Pretty cool, huh? Factoring by grouping. Factoring by grouping. Should we do another? Yeah. Yes, please. Okay, let's do it. Step 1, what do? Separate into 2 groups. So what's my first group? X to the 5th minus 2x to the 4th. Second group, leave a space, 2x, positive 2x minus 4. Okay, so I have my first group, I have my second group. Second step is to factor something out of both groups. You have to factor something out of there. Even if you can't, you have to factor out of one, right? But I could factor things out. My first group, what could I pull out? What's the GCF? X to the 4th. Okay. What will I have left over on the inside? X minus 2. That's right. And in my second group, what could I pull out? Bless you. Yes, A2, right? We're going to pull out a 2, and what's left on the inside? X minus 2. And that's great because we actually have a common binomial, which is our next step. The next step says, take a step back, pull out the common binomial that you see in both groups. So I want to put some exaggerated parentheses right here. I want to put that common binomial out here in the front, which is an x minus 2. So we're going to take these x minus 2s and we're going to pull them out. What's going to be left over? These guys come down and you're done. So what's on the inside? X to the 4th plus 2. Let's write it with the correct size parentheses. X minus 2, x to the 4th plus 2. Voila, we are done. Factored by grouping. Fun stuff. What else? Oh man, these guys down here. This is a real party right here. Factoring standard form quadratic trinomials when your a value is not 1. Okay? Now we know that when the a value is 1, when a is 1, it's ridiculously easy, right? All you do is think, what times what is 6? That if you add together is 5. Oh, 2 and 3, right? But that's because the a value is 1. If the a value is not 1, we have to go through a crazy, super fun, multi-step process. All right, so right here, your a value is 6. So you cannot say, oh, parentheses, x, x. You can't do that. Why not? Because x times x is not 6x squared, right? So we're not going to even bother writing down that factored form format. What we are going to do is follow the steps written above. Okay, step 1. Step 1 says multiply a times c and get an answer. So everybody should write down right here 1, a times c, and let's get an answer. What is a times c? What is a times c? Negative 18. Negative 18. All right, so that was step 1. Multiply a times c, get an answer. We got an answer. It's negative 18. Step 2, think of the multiples of that answer. So here we go. Step 2, think of the multiples of that answer that combine to give you the b value, and the tip is to make a list. So how could I get negative 18? That could be negative 1 times 18, negative 2 times 9, negative 3 times 6, and that's about it, right? I made a list of the multiples of the answers that I got on step 1 by doing A times C. Now it's time to move on to step 3. Use that pair of numbers. Oh wait, which pair of numbers combines together to give us the B value, which is -7? So -2 and 9, that gives us a +7, which is the same number, but I want it to be a -7. So I have the wrong sign. I have the right number, the wrong sign, which means I have the right numbers, just the wrong signs. So change that to a plus, change that to a minus, and that's the pair of numbers that we want for step 2. Let's move on to step 3. It says use that pair of numbers to rewrite the value of B as 2 terms, giving you a total of a 4-term polynomial. What? Check it out. Let's rewrite this guy. It says 6x squared, but instead of -7x, I'm going to rewrite -7x as these 2 numbers with x's. So I'm going to rewrite it as plus 2x minus 9x. After all, 2x minus 9x is that -7x, right? And we still have the -3 as a C value at the very end. That's a -3 over here at the very end. Why would I want 4 terms instead of 3 terms? So you could separate them by grouping and factor by grouping. So now we got to go through that whole other process of grouping. So step 1 is to separate them into 2 groups, 6x squared plus 2x space minus 9x minus 3. And then step 2 would be to factor something out of each group. What could you pull out of there? 2x. What would be left over on the inside? 3x plus 1. What could you pull out of the second group? A -3. Excellent. And what do we have left on the inside? 3x plus 1. And it's important that we pull out a -3, because if we didn't pull out a -3, let's say you just pulled out a 3, then you'd have negative signs in here and they would not be the same exact binomial. You want them to have a common binomial, your first group and your second group, that is. So now that we have that common binomial of 3x plus 1, we could put some exaggerated parentheses. We could actually pull out that common binomial of 3x plus 1, and then you could bring down the 2x and the -3, and we have factored a quadratic trinomial that did not have an a value of 1. This does become 3x plus 1 times 2x minus 3. There's your factored form of that first one. Let's jump to number 2. Let's do number 2. I want to factor this, but the a value is not 1. So I have to go through that multi-step process. Everybody write down step 1, a times c. What do I get? Yeah, you know that a is 12 and c is -3. 12 times -3 is -36. This is the answer to step 1. If you go back and read the steps, step 2 is to make a list. Think of the multiples of that answer, which in this case is -36, that combine together to give you the b value, which is 5. But let's actually make a list of the multiples of -36. -1 times 36. -2 times 18. -3 times 12. -4 times 9. -5 times nothing. -6 times 6. Fun stuff. All those are the multiples of -36 besides changing signs. We'll change signs if we have to. Anyway, which pair of numbers combines together to give us the middle value 5? That will be -4 and 9, as is, right? We don't have to change any signs. So what do we do from here? We take our 3-term trinomial and convert it to a 4-term polynomial. How? By rewriting our middle value, 5x. We're going to rewrite it, instead of 5x, we're going to write -4x plus 9x. -4x plus 9x is the same thing as 5x. So let's rewrite the whole thing. 12x squared minus 4x plus 9x minus 3. Again, I changed the 3-term trinomial to a 4-term polynomial. Why would I do that? Because now that I have 4 terms, I could actually factor by grouping. So factoring by grouping, separated into 2 groups, 12x squared minus 4x, space, positive 9x minus 3. First group, factor out something. What are we factoring out? 4x. Second group, factor out something. 3. Okay, so what do I have left over on the first group? Pull out the 4x, you're going to have what? 3 with an x and minus 1. Second group, pull out that 3, you're also going to have a 3 with an x and a minus 1. Now we're going to do some exaggerated parentheses. We're going to pull out that common binomial that we see, the 3x minus 1 and 3x minus 1. We're going to pull it out here and write it once on the outside. That'll be a 3x minus 1. On the inside, what's left over? A 4x and a positive 3. So our final factored form is 3x minus 1 times 4x plus 3. Is it difficult? No. Does it get easier? Yes. Is it fun? Yes. You got to practice though in order for it to get easier. Is there a shortcut? Yes. But I think I want to wait for that shortcut till the next time. So we're on the last question of this front page. Should I multiply 12 times 10 and get 120? I mean, that's a possibility, right? But why not try to do the first type of factoring that we always try, which is pulling out the GCF. So what is a GCF right there? What could you pull out from the whole thing? Could you pull out x's from the whole thing? No. A 2. What's left over on the inside? 6x squared minus 17x plus 5. Now, why would I pull out that 2? Because now I could look at that blue quadratic trinomial and ignore the 2 that I pulled out and focus in on that blue quadratic trinomial and do the multi-step process that I just learned. Okay. So the multi-step process would be step 1 to multiply a times c, and that is a is 6, c is 5, that's 30. Step 2, think of the multiples of 30, 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 times 6. Which pair of numbers combines together to give us the middle value b, which is negative 17? The 2 and 15 will give us a positive 17. That's great, we got a 17, but we want it to be a negative, so we have the right numbers, just the wrong signs. Change it to a minus, change it to a minus, and that's the correct pair of numbers for step 2. Step 3 is to rewrite your trinomial, in this case the blue 6x squared, but instead of the b value being negative 17x, I'm going to rewrite it as what? Negative 2x minus 15x. Negative 2x minus 15x. And we still have the plus 5 at the very end. Why do I want to change 3 terms to 4 terms? Because now I could do factoring by grouping. Factoring by grouping, step 1 is to separate it into 2 groups. 6x squared minus 2x space minus 15x plus 5. Step 2, factor something out of both groups. Even if you can't factor something, pull out a 1. But you can pull out something from both groups. In the first one, we could pull out a 2x. What's going to be left over on the inside? 3x minus 1. Okay, and what could I pull out of the second group? A 5. But if I do pull out a 5, I will have a minus 5x. No, minus 3x. Now, but I don't want a minus 3x. I want a positive 3x. So what would be better to pull out than just 5? A negative 5. So let's pull out a negative 5. Then we will have that positive 3x. And then negative 5 times what gets us a positive 5? That'd be a negative 1. And now we really do have that common binomial of 3x plus 1. We do some exaggerated parentheses. We pull out that binomial of 3x minus 1. What's left over on the inside? 2x minus 5. And there's our factored form, 3x minus 1 with correct size parentheses, 2x minus 5. Voila. I hope you're not scared. I hope you understand this.